Yeah, hello everyone. A very good evening. Let's wait for a few minutes so that everyone can able to join this session. You can check on Google NPTEL SEM portal if it is available there. So from there, I think you can download, but it will not be available for 24 onwards. You will get, I think, any one of the years. So we are also getting. Hello, is it audible to others? Hello, is it audible now? So can anyone of you can confirm it whether I'm audible? Now it's better. Okay, so from I think only 1 year of the previous year questions you will get, but not more than that. We are also getting only the previous year paper, only 1 year. So whatever question I am taking, this is just previous year questions. but most of the questions are similar to this year, so just I'm not taking that one. But that type of question only will repeat. Some values and some notations may be different, but the assignments that you are getting and what we are solving, that is the only the previous year questions and based on the topics which have been covered. So you can go through that the week 1 to 12 these lectures, or you can see my the whatever questions I'm uploading in the drive. From there you can get. This one is only previous year paper. Okay, so let's start the session. So yeah, hello everyone, a very good evening. So my name is Pooja Verma. I'm PMR Research Scholar from IIT Kharagpur, and instructor for this course is Dr. M.K. Bhuvan, Department of Electronics and Electrical Engineering, IIT Guwahati. This is a week 11 live and interactive session on computer vision and image processing, fundamentals and applications. So I hope all of you have gone through this week video lectures. So this week is applications of the computer vision. Most probably the questions related to the neural network, backpropagation algorithm, and different pooling layers like max pooling, average pooling. So how we can solve that type of questions. So these are the some textbook and references that already we have seen many times. So let's solve the questions related to this week. So this is our first question. Question 1 is an input feature map of dimension 64 into 64 into 3 is passed through a 2D convolutional layer. The layer uses 32 filters of the kernel size 5 cross 5 with a stride of 1 and no padding is there. So determine the total number of trainable parameters in this layer, including biases. So how we can solve this question? Any idea? Or would you like to answer this question? How to proceed with this question? So how we can find the total number of parameters, or you can say the total number of trainable parameters. Okay, so let's solve this question. So to find the number of parameters in the convolution layer, yeah. So first we need to calculate weights per filter and then biases per filter, and then we will combine these two, then total parameters we will get. Okay, so first one is weights per filter, that is equal to kernel width into kernel height and multiplied by input channel. So can you tell that what is the kernel width and kernel height? It is there. So here it is a given. This is the input feature map dimension that is passed through the 2D convolutional layer, and the layer uses 32 filters of the kernel size, that is 5 cross 5. So that means the kernel width it is there 5 and kernel height is also 5, because we need to find out the kernel size 5 cross 5, and the input channels, that is it is a mapping dimension, so it is the our input channel. Okay, it is a dimension of 64 into 64. That means it is a dimension, and the input channel will be the 3 here. So we will get it like 5 cross 5 multiplied by 3. If we just multiply this, so 3, we will get 75 weight per filter. Now we need to calculate biases per filter. Per filter. So each filter, or you can say that each neuron has a one bias, right? Here, each filter has one bias terms should be there, right? So here, how many weights we have got? So 75, right? So 75 filters are there, weights per filter are there total, and there is a one, because 75 filters has a one biases. Each filter has a one biases. So total 76 bias, or you can say that parameters will be there into the bias. Okay, so to find out the total number of parameters, or you can say that total number of trainable parameters in the layer, the given layer, is equal to the, that is parameters per filter, or you can say that the total number of weights per filter and then biases per filter. The number of filters, actually here total number of layers that is used, that is 32 filters are there. So parameters per filter, that is this one, biases. So yeah, biases, or you can say that the parameters, there are total 76 parameters here total. So parameters per filter, so total 75, sorry, 76 here, total 76, because there are 75 weight filters plus one bias term. parameters per filter and number of filters. So this one is 76 and total number of filters that we have, the layer has uses 32 filters. So yeah, here multiplied by 32. So if you just multiply these two, so you will get 2432. Okay. Or otherwise, you can calculate the other way also, like weights per filter, how many weights. So that is, say, 5 cross 5 cross 3, that is total 75, and total weights for all the filters. So here, total the layer that uses 32 filters, so 75, right? 75 multiplied by 32, so you will get 2400 total weight, and then biases that each of the 32 filters has one bias term, right? So 32 bias are total, and then total parameter weights per plus biases. So 2400 plus 32, so 2432. In that way, you can also solve. Okay. So is it fine? So if you see that correct option is option B. This one is correct. If you want to solve the other way, so you can solve the other way also. So total weights for all the filters here you can calculate like this. Total weight for all filters. So here the layer uses the 32. So 75 multiplied by 32. So if you multiply, so 2400 is total weight. And now each of the 32 uses filter uses one bias term. The total bias will be the 32. If you add these two total, so 2400 plus 32, so 2432. From that way, you can also solve it. So is it fine to all of you? Any confusion? Is it fine? Okay, so I hope all of you have understand this question. Now moving to our next question. Now next question is, given the activation function that is fnet is equal to sigma net, and that is equal to 1 by 1 plus e to the power minus k dot net, where k is a positive constant, which expression represents the derivative of f dash net. So they are asking which expression represents the derivative of f dash net. F dash net is, that means derivative of the f net. So how we can solve? Anyone, any idea for this question? So here activation function is given already. Now we need to find the derivative of this expression of the given activation function. So and we need to find out the derivative with respect to the that net function. Okay, so let's solve this question. So the activation function that is given, that is equal to fnet, and that is also the sigmoid function that is equal to the 1 by 1 plus e to the power minus k into net, right? So now we need to find the derivative. So the derivative of f net is, that is dy d net, and that is also called f dash net, right? And so d by d net of this function 1 by 1 plus e to the power minus k dot net, right? So can we write it like this, d by d net 1 plus e to the power minus k dot net to the power inverse, right? We can write it. If we take it the numerator, so it will be the inverse, right? So now next we need to just take a derivative. So for net, so first we will take the derivative for the whole. So minus 1 will be the this one, and then 1 plus e to the power minus k dot net minus 1 and minus 1. So d by dt something to the power minus 1, minus 1, minus 1. So here will be the minus 2 will be there, right? And again this net function is inside the e to the power. So d by dt again we have to differentiate with d net. So 1 plus e to the power minus k dot net. Okay, now in the next step again we will differentiate it. So minus 1 plus e to the power minus k dot net to the power minus 2. And now again here it will be the e to the power minus k dot net into minus of k, right? Because the d by d net will be the 1 here, e to the power minus k. So here minus k minus. So minus and minus will be the k only here it will left. So k into e to the power minus k dot net into 1 plus e to the power minus k dot net to the power minus 2, right? Now again we can write it like this, e to the power minus k dot net divided by 1 plus e to the power minus k dot net whole square, because we have taken it in the denominator, so we can write it like this. Okay, so I'm just removing this upper part from here. I hope all of you have noted down. Otherwise, I can take one more slide. Okay, so that we have taken in the denominator. Now we can break down that function into this form. So k into 1 by 1 plus e to the power minus k dot net into e to the power minus k dot net divided by 1 plus e to the power minus k dot net, right? Because in the numerator there is a k dot e to the power minus k dot net divided by 1 plus e to the power minus k dot net whole square. So we can write it like this. It will be the same if we multiply. The same function will be there, right? So now we can write it k dot. It is the same function that we have taken. So 1 divided by 1 plus e to the power minus k dot net. So we can write it into the f dot net. We can write it because that is not further we cannot use. So now we have to just look into this. So we can write this function, this one also. So 1 plus e to the power minus k dot net minus 1, right? We can write it 1 plus e to the power minus k dot net. So if we cancel out minus 1 plus 1, so the function will be the same. That's why we have for the derivation or for the to solve this question we have just included this one. Now further we can write it f dot net, sorry, f of net into, so further this function can be written as 1 minus 1 by 1 plus e to the power minus k dot net, right? So if we just, if you want to solve this, so 1 plus e to the power minus k dot net minus 1 and 1 plus numerator will be same. So you will get the same function, this one. So this will be the answer loop. So you will, so this is just other method to represent this function. Okay, so you will get the same. So we can write it. This function can be written as in this form. So this can be written in this form, right? So now further we can generalize it. So f dot net into 1 minus, it is the same f of net that we have seen in our question. It is the same representation of the f of net, right? So we can write it with f of net, same f of net. So this is our whole procedure to solve. So let's see in the this one. So if you see, so option C is the correct answer. K into f of net into 1 minus f of net, right? This is one is the same, right, that we have solved. So the derivative of the given activation function this is when k is positive constant. So the expression that is represent f of net, f dash net, it is k into f of net into 1 minus f of net. Okay, so is it fine? Have you understand this question? How to solve this one? Is it fine? Can we move to our next question? Okay. Okay, so now moving to our next question. So now our next question is consider the following 4 cross 4 feature input feature map. So this is the input feature map that is a given 4 cross 4 matrix. So here in the question they are asking if max pooling is applied with 2 cross 2 filter and a stride of 2, what is the resulting 2 cross 2 output map? So here we need to apply the max pooling into this 4 cross 4 feature input feature map. So how we can apply? Anyone, any idea? Would you like to just convey it here? How we can find it? So max pooling means getting a maximum value from the given input feature map. So here they are asking the 2 cross 2 filter. So first we need to divide this 4 cross 4 input feature map into a 2 cross 2 filter, right? And then from each 2 cross 2 input feature map, we need to get the maximum value, and that will result a 2 cross 2 again output feature map. So so max pooling with a 2 cross 2 filter and a stride of 2 means the filter moves 2 steps at a time. That is stride 2 means the filter will move 2 steps at a time. So in the max pooling, we need to select the maximum value in each 2 cross 2 window with no overlapping. Okay, so what we will do first, we will divide this matrix into the 2 cross 2 matrix. So if you just divide it like this, so you will get the 2 cross 2 matrix again in this one. So I'm not writing it here. So you will get it is a 2 cross 2, one matrix 2 cross 2 with no overlapping. That means the stride 2 means the filter moves 2 steps. So first we filter select this 2 cross 2, get the maximum value and then move the 2 step. Then here the 2 cross 2 again get the maximum value. What is the maximum value in this 2 cross 2 matrix? So first 2 cross 2 matrix is 12, 28 and 12. What is the maximum value? value in this 2 cross 2 matrix. So here it is a 20. The maximum value is 20 here, right? In this matrix 20, and in this matrix 30, 0 to 15. So maximum value is 30, right? So here we will get 30. Now next filter is 34, 70, 12, 1112, 100. So here what maximum value we are getting? So this is 1112, right? So in this we are getting 1112. Now next matrix that we will got equals to 37, 4, 25 and 12. So here the maximum value is 37, right? So in this one we have got 37. So what is our output feature map matrix? 2 cross 2 output map matrix that we have got, that is the first 20, then 30, then here 112 and 37, right? So let's see in the options what which option is matching 20, 30, 1112 and 37. So if you see, option A is the correct answer for this question. So is it fine to all of you? So have you understand this question, or do you have any doubt? So can we move to our next question? Or if you have any doubt, you can ask. Okay, so I hope all of you have understand this question. So now moving to our next question. So our next question is theoretical one. So the question is, which of the following statements regarding training deep neural network is false? So they are asking now which one is a false statement. Okay. So option A is early stopping is a regularization technique used to prevent overfitting. Option B, in back propagation, weights are updated using the gradient of the loss function. Option C is convolutional layers are strictly invariant to all affine transformation, including rotation and scaling. Option D is autoencoders can be used for dimensionality reduction and are a form of self-supervised learning. Which option is a false statement in this question? At least try to give an answer for this question. At least try which option can be a false statement. Try to give answer for this question or try to interact. Then we will see detailed solution. Okay, now it's in option C. Yes, we will see. Anyone else? Okay, so let's see the detailed explanation of this question here. The explanation is we will go through the options. So option A is early stopping. It's a regularization technique used to prevent overfitting. So early stopping is a well-known regularization technique and it prevents the overfitting by stopping the training process when model performance on the validation set begins to degrade. So that avoids over optimization on the training data. So that is a correct. This is a true statement. Now next statement is in back propagation, weights are updated using the gradient of the loss function. So in the back propagation, as we know that is the standard algorithm for neural network, training a neural network, where the weights are updated based on the gradient of the loss function, and that is calculated using the chain rule. So that is also a true statement. Now, next statement is convolutional layers are strictly invariant to all affine transformations, including rotation and scaling. So, in the convolution neural network, that are primarily designed for translation invariance or rather than translation equivariance. Okay, so that is achieved through the weight sharing and pooling layers. So they are not inherently invariant to all affine transformations. So that particularly rotation and scaling. And they are learned to handle these transformations with enough data augmentations. So they are not architecturally strictly invariant to them. So this one is a false statement. So yeah, now that is a correct. Option C is the correct answer for this question. So this is a false statement. So let's see the other statement as well. Option D, that is a autoencoders can be used for dimensionality reduction and are a form of self-supervised learning. So autoencoders that are artificial neural networks used to learn efficient data codings in an unsupervised manner or a form of self-supervised learning. So they are widely used for dimensionality reduction by mapping input data into a lower dimension in a latent space. So that is a correct statement. So the false statement regarding the training deep neural network is convolutional layer that are strictly invariant to all affine transformation, including rotation and scaling. So yeah, option C is the correct statement because it is a false statement regarding the training deep neural networks. So yeah, option C is the correct statement. So I hope this is a theoretical question. So it is clear to all of you. So moving to the our next question. So our next question is in a standard three-layer network, if WCI represents the weight from the input to a hidden layer, J input layer I that is to the hidden layer J, and the WKG that is represents the weight from the hidden unit J to the output unit K. So they are asking what is a mathematically correct expression for the output at node K, where F is the activation function and W0 are the biases. So which one is a correct expression for the output at node K for the standard trillion network? So can you tell that? Would you like to guess for this question? Then we will solve it in detail. At least try to give answer for this question. Okay, Ninad, it's B. Okay, yeah. Okay, let's solve this one as well. So, based on the structure of the standard three-layer network, So that is a feed forward network, as we know that. So with a single hidden layer and one output unit, that is K. So it is a three layer, so that means one is the input, one is hidden layer, and another out layer is output layer, right? So first we will see what will be the function to the input to the hidden layer. Okay, so input to hidden layer. So the net input to the hidden layer unit J is the weighted sum of the input xi plus biases, right? So the net input to a hidden, that is a unit J, is the weighted sum of inputs, that is a xi plus biases, that is wj0, right? Because the it is a bias to the hidden layer first. So it is a simply represents that I is equal to 1 to d, that is number of the input, wji, that is a weight to the input to the hidden layer for each input, plus bias wj0, right? And this sum will pass through the activation function, will pass through the activation function f, that is given. So this is our whole input to hidden layer. So summation of I is equal to 1 to d wji into xi plus wj0. Right. Now next we need to find the hidden to output layer. Right. What will be the function to the hidden to output layer? So the net input to the output unit K is the weighted sum of the hidden unit plus activation function and its own biases, right? So the it will be the K is equal to 1 to X, that number of channels, W, K, Z, and total output that we have got from the input, right? So that this is this function, right? So F into I is equal to 1 to D W J I X I is WJ0. This is from the that out that we have got from the input, right? And plus its own bias WK0. That means from the hidden to output, right? So this is a hidden to output layer, and the final output will be the then it will pass this sum again will pass to the activation function. So if you apply the activation function here, so this is the whole function, right? The final output yk at node yk will be the activation function and this whole function. So activation function and then summation of j is equal to 1 to x wkj, that is a bias that from the hidden to output layer, output node k, and activation function the whole, the input from the input to hidden layer that we have got, and plus bias. This is so Janina, this is a option B is the correct answer for this question. This one is a final output. Okay, so is it fine to all of you? Have you understand? We are calculating from the input to hidden layer to the output. Is it fine to all of you? Or any confusion, any doubt? Any doubt or any confusion? You can ask, otherwise we can move to our next question. This is a back propagation layer, right? So the representation from we will move to I to J, but the notation that we will use, that is a J to I. Okay, let me like let's say it is an input layer. This one is a hidden layer, right? And this one is output layer. Input layer, hidden, and this one is a output layer. So input layer is I, hidden layer is J, and output layer is K, right? So we will move like this only. But representation that we will use, that is from J to I, like this. But moving from here to here, moving to left to right. Okay, like input is Xi in this case, X1, X2, Xn. So, but in the bias, we will use the J to I. That's the back propagation. That's why it is calling it back propagation. Not this region, but we are moving to the opposite one. Okay. Okay. So I hope all of you have understand. So now moving to our next question. So now our next question is, in a structure similar to an XOR gate model, which weights, that is a V bias Vx1, Vx2, that is given, would model an AND gate, that is where output is 0 only if both inputs are 1, or both inputs are same, you can say that. It is a XOR gate. Okay, no, the would model the an AND gate they are asking for. So they are saying that in a structure similar to an XOR gate, so the structure will be similar to XOR gate, which weights, and that weights are the, and would model a NAND gate. So how we can solve this one? So as we know that in the NAND gate, if output will be, if both inputs 1, then output will be 0, and if any one of the input is 0, then output will be 1, right? In a NAND gate. So it is a 0, 0, 0, 1, 1, 0, and 1, 1 for a NAND gate. So expression is A, B bar, right? So here it is a 0, so 0 will be the 1. So just it is working. Just a minute. So output will be here. So output will be going here, right? This is it. It's truth table for NAND gate. And the output for if both inputs are 1, so output will be 0 here, right? Now, what we need to do, we need to find the output from here. So we will go through the options, right? So as we know that in a simple perceptron model, the output is typically determined by the activation function. So here we will use the activation function f of z is equal to 1 if z, the value that is output, is greater than 0 and 0 otherwise. If it is a negative value or something else, so can you give me some time? Actually, my pen has stopped working, so I'm not able to write. Okay, so I'm just writing here for full function. The f of z is equal to 1 if z will be greater than 0 and 0 for otherwise. Okay, so as we know that the function will be for the neuron person, so weights plus biases. So two inputs are there, that is a Vx1, Vx2. So Vx1 into x1, this is x1 plus Vx2 into x2 plus V bias term, right? So for from this criteria, we need to check whether this will act as a NAND gate, which input combination will act as a NAND gate, right? So first we will check for option A. So here the output will be, first we will take here, let's say it is a x1, just a minute, where I'm just removing it. It is a x1 and this one is a x2, right? So for option 1 we are first taking 0 0, right? So Vx1, let's say is here, it is a given that is a V bias x1 value and x2 value, right? Because here it is given in this form, that's why it is following the same. Okay, first we will take the here, so Vx1 is minus 1, here it is given, and x1 is 0, right, into 0 plus again Vx2 is minus 1 and the again x2 is 0 plus V bias, that is a 1.5. 1.5. So what we will get here, overall value is 1.5. So that is a Z, our Z, right? This is a Z. So Z, so it is greater than 1 here. You see, can say that greater than, sorry, 0 here, right? So that means the overall output of the activation function, that will be the Fz will be 1, right? Now check for the other also 0 1 then 1 0. So for this one we have got the 1. Now we will take a here, for the same we have checked for all four combinations, right? So again x1 is 0 and x2 is 1, just we need to put in this equation. So here you will get 0 minus 1 plus 1.5. So here you will get 0.5 z value, and if you apply the activation function, so in the activation function what it is, if z is greater than 0, so it is a less than 0, so that means the activation function will give the output that is equal to 0. Okay, that is a 0. No, it is a positive value, so z should be greater than, so it is a 0.5, so it will give the output 1 here, not a 0, 1. It is greater than 0. If it is a negative, that means, so it is again will give the output 0. So it is a correct 1 and 1 again. So if you just reverse this one, so again you will get here 1, 0. So again you will get the 0.5 and activation function. It is a greater than 0.0. So here again you will get the activation function will give the output 1. So it is again correct. Now if you take 1, 1 here for the next combination, so 1 into 1. So what you will get here, minus 1 and minus 1, minus 1, minus 1, and overall you will get minus 2 plus 1.5. So here you will get minus 0.5. It is a minus 0.5, which is a less than, it is a negative number, so output will be the activation function will give the output 0. Okay, so it is following the NAND gate truth table. So option E is the correct. Now, if you want to further verify for the other options as well, so you can just take for the other input combination for B, C, and D. So I'm just going through that one option and more option to make you understand how it will work. So let me just give me a few. So it will not working. It is not feasible to write like this. Then we will solve for other option. Then we'll let you know, okay, what the other. Okay, it's not working. So let me go through the for the other options as well. So just we need to change the functions. So can you check with the other input combinations as well and let me know how it is working? So it is a V bias. It is there. So for the, let's say option V, we can check, and the here V bias is minus 1.5, and input Vx1 and x2, Vx1 is 1, Vx2 is also 1. So for the option 2, so here Vx1 is, here it is a Z, so Vx1 is 1, and for the first input combination for all the, that is a 0, 0, 0, 1. So first input combination is 0. Now next Vx2 is also 1. So 1. So again here we are taking for the calculating for the input combination 0, 0. So 0, and here again the V bias is minus 1.5, right? So if you just calculate, so you will get minus 1.5. So if you just apply the activation function f of z, so it is a negative number, so it is a less than 0, so you will get the output 0 here for the first one. So here 0. Now, if you check for the other input combinations, so again, but you will 0 and 1. So 0 and 1. So 0, so 1 minus 1.5, again minus 0.5, it is a less than, so again activation function will give the output 0. Similarly for 1 0, just input, so again you will get minus 0.5, again the output will be the 0. So we have got three zeros in a row. And now next we will check for the input combination 1 1. So 1 into 1, so here 2, 2 minus 1.5, so here you will get plus 0.5. So in that case, the activation function will give the output 1. So what we have got 0, 0, 0, 1 for the for the option B. So it is related to which gate? It is a not a NAND gate. It is opposite to the NAND gate, right? So it is a AND gate. It is a for AND gate. So now if you check for the option C, so here you will get the combination for this one OR gate, and for this one you will get for the NOR gate. Okay, so only for option A is giving a correct, that is a an NAND gate expression. So option A is the correct answer for this question. So is it fine to all of you? So I can write here, it is giving the NAND gate, and this one is giving the AND gate. So they are asking in the question, which model give an AND gate? So option A is giving the AND gate expression. Okay, so is it fine? So have you understand this question? Is it fine to all of you? Have you understand? Actually, I'm facing little bit problem in writing. So is it clearly readable or understandable or not? Just let me know. Is it fine to all of you? Okay, so I hope all of fine and understand this question. So now moving to our next question. So our next question is, a layer receives an input of the 32 into 32 into 32 64. It applies a 128 filters of size 3 cross 3. How many parameters are in the layer? So any one of you can tell. How we can solve this question? So here the input of the layer that receives, that is a combination of 32, 32 and 64, and it applies, they have 128 filters of size. Filter size is given as 3 cross 3. Now they are asking how many parameters are in this layer. So each filter must have a same depth as the input volume, right? So with an input depth of 64 and the filter size of 3 cross 3, the total number of weights in a single layer. So filter size is 3 cross 3 and input depth is that is a 64, that 64 layer. So that is a total 64. So how many layers will be there here? If you just multiply, you will get 576 total weight per filter. That is it, weight. Okay. So 576 is the total filter. And as we have solved this one previously, so each of the filters typically include one bias. Each filter that is typically include the one filter, right? Sorry, one bias parameter. So each filter includes one bias, right? So 576 plus 1, so 577 parameters. So total parameters for the filter per filter is 577 parameters. I'm just writing parameters per filter. Okay. So now the layer applies the 128 filters, right? The total number of parameters. So total number of parameters is equal to, so 576 multiplied by 128, right? So if you just multiply, you will get 70. So just if you multiply these two, so you will get 73,856. Okay, total number of parameters. If you multiply, so if you see that only option B is the correct answer. So no, option A, it is a 73,856. So option A is the correct answer for this question. Okay, so we have solved previously one question on this. So is it fine? I hope you can understand this question. Already we have solved one problem on this. So now moving to our next question. So our next question is a input image of size 224 into 224 into 3 is passed to the convolutional layer with 64 filters of size 7 cross 7, stride 2 and padding 3. What is a special dimension, that is a width and height of the output feature map? How we can find the special dimension of the output feature map? So to find the special dimension of a feature map of the convolution, there is a one formula, that is a for output dimension, that is a I minus k plus 2p divided by s in the modulus plus 1. Okay, so the formula to find the output feature map, that is O is equal to in I, so I minus K plus 2P divided by S plus 1. This is the output feature map. Output feature map. Okay, this is the formula. So here I is the input dimension. I is input dimension and K is the filter size and P is the padding and S is the stride. Okay, so here it is given the input dimension, right? 224 into 224. So input dimension is the 224 and filter size that is 7 cross 7. So filter size is 7. Padding here is given as a 3 and strides that is given as a 2, right? And input dimension is 224. Now put all these values in this one and calculate it. So if you put here all the values, so 224 minus 7 plus 2 into 3 divided by 2 and plus 1. So now again, if you just multiply and add and all those things, so you will get 223 by 2 plus 1 and here you will get 115 plus 1. So it is a triple 1.5. Okay, so if you just it is a modulus function, so you can directly take triple 1 plus 1. So overall you will get here 112. So output feature map, the special dimension output feature map will be the 112 multiplied by cos 112. The output feature map dimension that we have got, that is a 112, and it is written by the width and height. So it is a 112 cross n12. So if you see, option A is the correct answer for this question. Okay, so is it fine to all of you? So yeah, it is a total. What will be the dimension of the output feature map? Length and width. Not it is a total number of parameters. It is the total number of parameters that we have calculated in the previous question. Now we are calculating the special dimension out for the output feature map. That is dimension for the output layer, basically. Okay. Okay, so is it fine now? Can we move to our next question? So I hope all of you have understand. So now moving to our next question. So our next question is here again. Which of the following is true regarding the Cohen self-organizing map, that is a Cohen zone? So option A is that it uses supervised learning to classify labels. Option B, it uses competitive learning strategy where only the winning units wait and its neighbors are updated. Option C, the learning rate alpha t usually increases over time. Or option D, it requires a fully connected backpropagation path. Which option can be a correct one? Okay, now that's in option B. Okay, so let's wait for a few seconds so that if anyone else want to answer for this question, then we will move to the detailed explanation. Anyone else would like to answer for this question? Which of the following is true regarding the coherent self-organizing map? Okay, so let's see the detailed explanation. So, yeah, option B is the correct answer. So we will move to the options wise. So first option is it uses supervised learning to classify labels. So in the coherence zone, that is a self-organizing maps perform unsupervised learning, not a supervised learning. Okay, so they learn the underlying structure of the input data without needing labels. So it is a incorrect information. That is a false statement. Now option B is it uses a competitive learning strategy where only the winning units, weights and its neighbors are updated. So in the coherence zone that uses competitive learning where the neurons in the output layer compete to represent the input data. Okay. So the neurons with the weight vector closest to the input vector is selected as a best matching unit or a big winner. So during the update step, only the winning neurons and its neighborhood, that is defined by a radius, had their weights updated. So that is a correct statement. This is a correct one. So we will see the other options as well. Option C is the learning rate alpha t usually increases over time. So the learning rate alpha t and the neighborhood radius typically decreases over time to ensure that map converges and becomes stable. So this is also the opposite statement. So this one is a false as well. So option D is it requires a fully connected back propagation path. So that is a Cohen zone uses competitive learning, not a traditional gradient descent based propagation. So it is not a back propagation algorithm. So this one is also false. So the correct statement regarding the Cohen self-organizing map is that it uses the competitive learning strategy when only the winning unit weights and its neighborhoods are updated. So yeah, option B is the true statement and correct for regarding the Cohen self-organizing map. Okay, so is it fine to all of you? So I hope it's a typical question. So it is understandable. So now moving to our next question. So the next question is given a network where output is equal to x plus 1 into y plus z. If x is equal to 1, y is equal to 4 and z is equal to 2. is given, what is the gradient of the output with respect to x? They are asking what is the gradient of the output with respect to x. So how we can solve this question? So it's simple. Here the output function is given of the network. Now they are asking the gradient of the output with respect to x. So that means we have to take the derivative of this output with respect to x, right? It is given. So the given function is that is output is equal to x plus 1 into y plus z. Okay, so they are asking the gradient of the output with respect to x. So that means del output by del x, right? So if you take the derivative with respect to x, so it is a x into y, right? If you multiply, so here y only left and x into y, so no x term will be, so that will be 0 and this term is also 0. So only left y. The y value that is given, y is equal to 4. It is a given. So this one, right? So what is the gradient of the output with respect to x? That is a 4 because we have got del. If we differentiate with respect to x, so only y we will get and y value that is given 4. So option B is the correct answer for this question. Is it fine? It is a simple one. Okay, Anima, it is a correct option B. Okay, it is a previous one. So have you understand? This is a simple question. So I hope it is a fine or understandable to all of you. So now moving to our next question. Now our next question is suppose you have an input as x, y and z. That these are the inputs x, y and z to the network given below. So calculate the gradient of the output with respect to x, y and z. They are asking we need to calculate here gradient of the output with respect to x, y and z. So first we need to find out here the output function here because function is not given, right? So here what will be the function? It is a addition operation and it is a multiplication operation, right? And inverse operation it is given, right? So here the what we will get here x plus 1 it is adding, right? So here what we will get here x that is a x plus 1 we will get here before inverse and inverse after inverse operation what we will get here 1 by x plus 1, right? We will get here x plus 1 and then this inverse operation is multiplied by y and this one will be the multiplied. So that means here we will get y into 1 by x plus 1 and again one addition is there, so after the final output here, so here the y uh, we can say some other terms we need to take final output. Let's say A is the final output. So A is equal to y by x plus 1, and here it is addition operation, so plus z. So this is our final function of this network, right? So this we have got. Now they are asking to calculate the gradient of the output with respect to x, y and z, right? So let's calculate. First we can calculate. We will go, it is a batch propagation algorithm. So we can calculate via first dy by, let's say del A by del x. First take a gradient with respect to x, y and z in the question. So if you just take a inverse, so y into x, let's solve for the first this equation plus z, right? We can write it like this, right? So now if you take the derivative with respect to x here, so what we will get, y into x plus 1 to the power minus 2, and here it will be the 0, right? Because no x term is there, right? And it is a minus, so minus 1, so minus will be the inside, and x, so that will be the 1. So overall that we will get y by x plus 1 whole square here, right? That we have got. Now the values are given, y values that is given, that is 3 equal to 3. So 3 by x value is given 2 plus 1, right? So 3 square. So here it is a minus sign will be there. So here overall we'll get minus 1 by 3 here, minus 1 by 3. Del L by, or you can say del A by del X, we have got minus 1 by 3. So I'm just writing it here. So we will again is not required for this. So del A by del X that we have got minus 1 by 3, right? Del A by del X that we have got minus 1 by 3. Now del A by del Y. Now we need to take a gradient with respect to Y. So if we take a gradient with respect to Y, so what left? It is a 1. So 1 by x plus 1 only left, right? And this function will be 0. So x value is 2. So 2 plus 1, that is a 3. So del A by del Y is 1 by 3 that we have got. Now similarly take a gradient with respect to del A by del Z. Okay, so if you take y, so this term will be 0, this term only 1 is left, right? So the value that we have got minus 1 by 3, 1 by 3 and 1, right? It is a del A by del X, it is a del A by del Y, and this is a del A by del Z. Okay, so let's see which option can be correct. If you check, you will get option C is the correct answer for this question. Okay, so is it fine to all of you? Have you understand this question? Is it fine or any doubt? Okay, so I hope all of you have understand this question. Now moving to our next question. Our next question is again the already we have solved one problem based on this. The question is an input of 74 cross 74 cross 70, 32 is passed through a 3 cross 3 convolution with this stride 2 and no padding is there. What is the special dimension of the resulting feature map? So again they are asking for the output feature map, right? So we know the formula for the calculating the output feature map, that is a O output feature map, that is O of I minus k plus 2p by s plus 1, right? So here I is the input feature, k is the and k is the I is the input feature map and k is the filter size and p is the padding and s is the stride, right? So here no padding is there, so p will be 0. Input that is given, that is a 74. So 74 minus k, k is the filter size, that is a 3 plus 2 into here no padding is there, so that means it is a 0, right? So and s stride is 2, so plus 1. So 74 minus 3 will be the 71 by 2 plus 1. Now if you just calculate, so you will get 35.5. So here if you just take it out, so 35 plus 1, so 36 total. So output feature map will be the, I'm just calculating special feature map, so 36 by 36. Okay, so you check option A is the correct answer for this question. Is it fine to all of you? Actually, I'm facing a problem in writing, so my pen stopped working. I'm not able to write efficiently. Just trying to write it, all those things. So I hope is it clear and it is clearly visible. Writing is little bit sophisticated, but I hope it is understandable, right? Is it fine? I hope it is fine. So now moving to our next question. So okay, our next question is for a cohenome with two cluster units, a weight vector that is for a cluster 1 that is a 0 0.2 and 0 0.8, and for cluster 2 the weight vector is 0 0.6 and 0 0.4. If the input vector of x that is given 0 0.5 and 0 0.5, which unit is the winning neuron based on the Euclidean distance? So they are asking which unit is a winning neuron based on the Euclidean distance. So now we need to find out the Euclidean distance between the vector 1 and input vector and then vector 2 to the input vector, right? So here they have asked in the question for the in a already given using the Euclidean distance. So in a coherent self-organizing map, the winning neurons or the best matching units is one whose weight vector has a minimum Euclidean distance to the input vector. First, we will calculate distance to the x and weight vector w1. So distance distance to W1 and X. Okay, so I'm just representing it D1, right? So as we know that Euclidean distance root of so X minus W1, I mean this one, X at X position and Y position, right? So, 0.5 minus 0.2 square plus 0.5 minus 0.8 square. Now root of 0.3 square plus minus of 0.3 square, right? So if you just for the 0.09 plus 0.09, if you just calculate, so 0.18, and the value that you will get, that is 0.4243. D1 that we have got 0.4243. Okay. Now similarly we need to calculate for the distance to W2 and vector X. Okay, so just remember that is a distance D1, that is D1 is equal to 0.42. Okay, now similarly we need to calculate for W2, and just I'm removing the one. Okay, so 0.5 minus weight vector for the X position 0.6, and here 0.4, right? So 0.5 minus 0, so minus 0.1 here, and here 0.1, right? So just here minus 0.1, 0.1. So if you just take the square, 0.01 plus 0.01, so here we will get 0.02. Now if you take a root, then you will get 0.1, 0.14 and 14, 14 and the 14. So it is a D2. So D1 that we have got 0.42 and D2 that we have got 0.14. So D2 is less than D1. So D1, so D2 that means is the winning neurons, right? It is a more closer to the vector, So unit 2, that is a unit 2 is a more closer. So D2 that is a unit 2 is the winning neuron. So option B is the correct answer for this question, right? So is it fine? Have you understand this question? Just calculate the Euclidean distance. Whatever the minimum distance, that means that is a more closer, that is a winning neuron and more closer to the vector, right? It is a fine. Is it fine to everyone? I hope all of you understand this question. Now moving to our next question. Okay, so our next question is The given structure depicts an XOR gate modeled using neural network. Now they are asking find the values for V1 to V9, so this weight vector, to get the desired network. So they are asking this is depicting the XOR gate. Okay, so we have to choose V1 to V9. That in that case, this whole function will act as a XOR gate, right? So first we will see what is the truth table for the XOR gate. X1, X2, and let's say it's Y. So it is a if input combinations are different, then it will produce the output 1, otherwise it is a 0, right? This is a XOR gate, and we also know that XOR gate is represented by x1 dash x2 plus x1 x2 dash, right? Now each neuron in this one, already we know that it is a weighted sum of the input weight vector plus bias, right? So what will be the input combination for that one? Okay. So first we will calculate for V8 for this neuron. You can say that V8. So it is a V3 into X1. Let's see what is V3 into X1 at this AND gate. What is the input combination that we are getting? V3 into X1, X1 plus and V5 into X2 plus this bias plus V1, right? And V8 that this neuron acts as a NOR gate, right? So at V9, what is the input combination that we are getting? V4 X1 plus, right? V6 into X2 plus V2. This is a combination for the AND gate that giving, and this is a combination for NOR gate. And overall output will be the that is equal to V8, and this is the overall output plus V9 plus V7 plus bias. Bias is the V7, right? Now, as we know that for the AND gate, the input, if both inputs are 1, then output is 1, otherwise it is 0, right? And for the NOR gate, if both inputs are 0, then output 1, otherwise the output will be the 0, right? And if for the similarly for OR gate, we know that if both any one of the input is 1, then the output will be the 1, right? So now we need to take the different combinations here. So to check what will be the, in that case, the output will be. Okay, so if you see in the diagram for the AND input neuron for this one, the combination is V3 and X1 plus, that is or V5 into X2 plus V1, right? So that we need output 1. So for that, both the inputs should be 1, right? Otherwise it will be the 0, right? So here X1 is equal to X2 is 1. Already we know that. So what this overall this neuron will for what input combination? this neuron will produce a positive output. So for this one, what we need to choose for V3 and V5? V3 and V5 will be the one, right? So if we choose V3 is equal to V5 is equal to 1, and V1 if we choose is equal to minus 1, and if you put in this case here what the function that you will get, just you need to put it and check for the different outputs. Okay, so here 1 you will get 1 and minus 1, so overall 1, so output is positive, right? So in that case this combination we can take. If you take 0 1 and minus 1, so that will be the 0. This is the correct, and then if you take opposite and then if you take that one, so you will get the output 0 for this combination. Okay, if you choose V3, V5 is equal to 1 and V1 is equal to minus 1 here. Similarly, we need to check for the NOR, this one, NOR input neurons, right? So as we know that the NOR input neurons, if both inputs are 0, right, then output will produce a 0, right? So here if we take the 0 0, so V4 and V1, what would be the V4 and V6? If we take here V4 is equal to and V6 is equal to minus 1 and V2 is equal to 1. So now if you put 0 and 0 plus 1, right? So output will be the positive. If we take V4 and so it will be the minus 1. And if you check for the other combinations of 0 0 0 1, so 0 and here minus 1, so that will be 0. That should node will act as a NOR gate truth table. Okay, so if you take this combination, I have checked, you can go through and check it. So you will get V4 and V6 if you take minus 1 and V2 is 1, then you will this node will act as a NOR gate. Now similarly, if you check for the OR gate, this one, this neuron, so if you take V8, that is equal to 2, V9, because we have to generate a positive number always, 2, and V7 is equal to minus 1, V7 to the. So here, so if you take 2, 2 and minus 1, so 2 plus 2 minus 1, so 4, so it will be the 3, and the different input combinations as well, because these we need to go through that all also. Here it is multiplied by the activation function in this one V8, the all the input combinations as well. That is a very long function if we write it. Okay, so if we take a strong positive number, that we need to use 2 for in this case, because all the we need to take all the consideration here. So if you choose like this, then you will get this overall function will depict as a XOR gate. Okay, so I'm just removing it from here. Just you have to check in this whole function. So I can write here what will be the different values. V1 is equal to minus 1, V2 is equal to what we have chosen is 1, V3 is equal to 1, V4 is equal to minus 1, V5 is equal to 1, V6 is equal to minus 1, V7 is equal to minus 1, and V8 is equal to 2, and V9 is equal to 2. For these values, this function, this overall that this given structure will act as a XOR gate. Okay. So if you just write in this form the all these values, so v1, so -1, -1, sorry, it is a +1, -1, 1, then 1, -1, 1, -1, -1, 2 and 2. So from for these v values from v1 to v9 will get a desired XOR gate. If you check, so which option can be correct one? -1, then 1 1, -1, 1, -1, -1, 2 2. So if you check, so option C is this one is a correct answer for this question here. Is it fine to all of you? Have you understand this question? Or if you have any doubt? So you just remember the AND, NOR and OR gate truth table and take the x1, x2 these values from there. Just take the combinations here and check which option is matching that, which option is giving the XOR gate for this structure. Because if you take 1 or -1, that is not giving a positive result, because we for OR gate, as we know that any one of the value is 1 in the truth table, that will get a positive number, right? 1 in a OR gate truth table. So if you check for all these combinations v8 to v9, so if you take 1 or -1, that is giving a negative result. So that is a not fulfilling the criteria of the truth table of the OR gate. So that's why we have to take the strong positive number there. So that is a other one if you choose to. So for all the cases if you check, so there you will get a positive number. That means output is 1. That's why we have chosen 2 here. Just once solve in a pen paper, then you will understand that one. Okay, now. So let's move quickly to our next question. So now again, our next question is consider the 4x4 feature map below. If the average pooling is applied with a 2x2 filter and stride is 2, what is the output of at a top left position? So they are asking what will be the top left position. So already we have solved one problem in this, but there is a maximum pooling is there, right? Here the average pooling is given. So again, what we need to do, we need to divide here 4x4 feature input map is given. Now they are asking if average pooling is applied with a 2x2 filter. So first we will divide it into a 2x2 filter, right? So just divide it, take a two different 2x2 filters with stride 2. Stride 2 means that what we have told. So stride 2 means the filter moves 2 steps. So from 2 steps from here to here at a time. Okay. So stride 2, that is the meaning of the stride 2. Now we have to calculate for all 2x2 filters the average value, average pooling. So what is the average number for this first filter? First filter is 4, 8, 12 and 16. Calculate the average value, sorry, average value. If you take all the summation 4 plus 8 plus 12 plus 16 by 4. So here they are asking what is the output of the top left position. So top left position is this one only, right? So for this one we need to tell only. So if you just add all these values, so 12, so 8, 4, 12, 12, 24 plus 16. If you add, you will get here 40. So 40 by 4, so you get the 10. So the output for the top left position, so this one, top left, so this one. So the average pooling value is 10. If you check in the options, you will get option B is the matching with this question. It is fine to all of you how we are calculating these values. Is it fine to all of you? I hope all of you are understand this question. So actually I am facing the issue. I am not able to write it. So I am just closing for this week till this question. The other five questions are left. So I will cover in the next week the other five questions with the next week questions. Okay. So these are the other five questions that I have taken. So I will cover it because I'm not able to clearly write. It is the derivations are large, so I will cover it into the next week. So now if you have any doubt, you can ask. Otherwise, we can close the session. So thank you everyone. Thank you for joining this session. If you have any doubt, you can ask now. Otherwise, we can close the session. Any doubt? The next five questions I will cover. Okay, for the previous question, I am not sure how to approach solving the question. Okay, question number 13, right? This one, 13, it is a simple. I mean, you have to take a Euclidean distance. Okay, it's question number 14. Okay, sure. So what you are not getting here now for this question, what we need to do, the structure is given. We need to find out the values of the V1 that is a weight of V1 that is a weight as we know that V1 to V9. So that for any input combination here two inputs are there for the two input here. As we know that what are the four different combinations that is a 0 0 0 1 and 1 0 that input combinations are fixed, right? Now we have to choose the v1 to v9 values so that this whole function will act as a XOR gate. That means that whole function will mimic as a XOR gate. Okay, so v1 to v9 we have to choose for the what different combination, for the four different combinations, that is a 0 0 0 1 1 0 and 1 1, right? And this function should be acts as a AND gate, this neuron, and this neuron will act as a NOR gate. So AND gate, we know that what is a truth table for the AND gate? Just so AND gate truth table is 0 0 0 1 1 0 and 1 1, right? So 0 0 0 and 0. Let's say it's the x1, our x1, it is a x2, and this is the output, right? And in the AND gate, as we know that for the only input combination 1 1, the output will be the 1, and we need the here the 1 and all other combination. So already the weights plus ices, that equation I have written. So just write down that and check for all the input combinations and the given that we have chosen. Or you can choose the different 3, 3, 3, 5, V1. So for that we have to check by the options as well. Okay. So for what combination this will act as a AND gate. Similarly, for the NOR gate we have to write and check it. And if these two are completed, then go to for the this OR gate and check what will be the values that will give the result for the or the final output. Okay. So if it is not clear, I will cover it once more in the next week questions. Next week with the next week questions. Is it fine now? Ninad? Okay. So just check with the pen and paper, then you will understand more how it is working. Anyone else? Any doubt or any suggestions or anything you want to share or you want to tell? If not, so we close this session now? Okay, so thank you everyone. Thank you for joining this session. Now I'm closing this session. So if you don't have any doubt, you can leave the session. Swati and Mohit, any doubt? Okay, so I hope all of you have no doubt. So thank you everyone for joining this session. Now I'm closing this session. Thank you for joining this session.